Hello everyone, today I am going to discuss about asymptotic notation. Whenever we want to perform an analysis of an algorithm, we need to calculate the complexity of that algorithm. But when we need to calculate the complexity of that algorithm, it does not provide the exact amount of source required. So instead of taking the exact amount of the source, we present the complexity in general form, which is also known as notation, which produces the basic nature of that algorithm. And we will move to the next slide. Asymptotic notation, majorly we use, there are three types of the notation. First one is big O, big omega and big theta. In big O notation is used to define the upper bound of algorithm in terms of time complexity. That means big O notation always indicates the maximum time required by algorithm for all input values. It describes the worst case of algorithm time complexity. And we should see the next notation. Here is the it is the graph of the big O notation. The graph is drawn for the values of f of n and g of n for input of n value on x-axis, and time is required on y-axis. And always see g of n is greater than f of n, which indicates the algorithm's upper bound. Example, if f of n is equal to 3n plus 2 and g of n equal to n, we have to satisfy the f of n should be lesser than or equal to g of n for big O notation. Next we have the big omega notation. Is used to define the lower bound of algorithm in terms of time complexity. That means always indicates minimum time required by algorithm for all input values. Describes the best case of algorithm time complexity. It's similar to the big O notation, but it's completely opposite. And we have the graph, and I think f of n should be lesser than or equal to g of n, and it represents the low bound. And example, if you take 3n plus 2 and g of n equal to n, then f of n should be greater than or equal to c of g of n to satisfy big omega notation. And last chain notation we have big theta notation. This is used to define the average bound of algorithm in terms of time complexity. That means it always indicates the average time taken by an algorithm for all input values. That means big theta describes the average case and algorithm time complexity. And we have the graph for big theta notation. Graph is drawn for f of n and cg of n, input value on x-axis and time required on y-axis, and it represents the average bound of time complexity. And we have here some example. It should be, the condition is should satisfy g of n should be lesser than or equal to f of n should be lesser than or equal to c2 of g of n. Here are the some condition for big O notation, big omega notation and theta notation. And we have graph. Common asymmetric notation, constant, logarithmic, linear, n log n, quadratic, cubic, polynomial and exponential. And here the PPT ends. Thanks for watching.